Bismillahirrahmanirrahim. Assalamualaikum and very good day to the panels of judges and friends and participants of this MPI 2022. Today we would like to talk about our innovation on the interactive maritime training through IR. IR is augmented reality analysis simulation in enhancing GE. GE is the graduate employability and upskilling and reskilling in maritime industry towards IR4. In this innovation, which our team already undergo, it is regarding maritime training in the IR4 era, which is called for the technological advancement, which at the same time needs changing the way industry trainings and students in learning both physical and virtual environments. Innovative new pedagogy teaching and learning in which physical class session become interactive, creative, and provide more interactive experience of the real world environment, such as by applying the augmentative reality AR and at the same time simulation. Let's see the significance of this innovation package. It is to assist and to serve the maritime industry in instilling new digital tools of IR4 advanced technology. So at the same time, it is also supporting the government vision to upskilling and reskilling the workforce, especially in the key sectors of maritime industry. The next session will be explained by Prof. Wan Norsani on the augmented reality, that is AR. AR is relative seamless of digital object within a real world, encouraging interactive and engagement. It maximizes the student and the trainees' ability to spend their time learning circular objects or subject while minimizing the time spent learning in the class and how to use the new technology. Please, Prof, can you please explain us on that augmentative reality?
By using the augmented reality (AR), it increases students' interactivity and engagement using virtual experience. You will see on the top left photo, we use Korean technology to expose students of maritime technology and nautical by wearing goggles. Students can imagine and expect what to do when a ship about to sink. They are shown on the right photo. And the bottom photo, we teach students using softwares, free softwares in class. Examples of the softwares are Zapper and Prezi. However, my respective panels need to download free softwares before you try the sample sizes prepared by the students here.
For the ENT learning integration interactive delivery methods, we are combining between AR and SS simulation, which is in this case we are raising up, highlighted the full mission ship handling simulator, which will be explained by Hafiz on the ocean sites.
Thank you, Datin. Today, the use of simulators is mandatory for certain parts of the curriculum for maritime education and training and is regulated by international conventions, that is, by the Standards of Training, Certification and Watchkeeping for Seafarers, or STW. In order to ensure that future mariners are able to act in proper and safe manners, it is stressed in the STW that simulators are to be used for both training and assessment. One of the major recent updates of the STCW conventions, the 2010 Manila Amendments, has a greater focus on technical proficiency and so-called non-technical skills compared to the previous version of the convention. The technical skills relate to handling the equipment of the ships, while the non-technical are often described as cognitive and communicative skills, such as situation awareness and decision-making, as well as skills involving teamwork, such as leadership and communication.
So on the ocean side, just now, Chief Hafiz already explained to us. Now we are looking at the land side or port side. In this situation, in this package, we are using IR and simulation to do the simulation on the forklift component for lifting the containers from container yard to the warehouse. This is the activity on the land side, which are very interesting for the student without going to the field to see the exact or the actual situation, but they can use this application to have the reality experience of the field.
I teach students how marine fluid power works, i.e. hydraulic and pneumatics, and use hydraulic pneumatics in maritime industry. So the students will understand how industrial revolution advances from low-cost industrial revolution 1.0 to advanced automation in IR 4.0. I will show you after this the video clip. Normally, I bring students to lab, show them how the components work. This semester, I converted this experience into video form. So it's my pleasure to share with MPI panels the video that we just prepared.
As what Frog 1 and Cik Hafiz already explained the package interaction and interactive activity done by the student. The student fully involved in this package. So it is not only for one direct way of teaching, but now we have two types interaction from the student and also interaction from the lecturer to the student, and it also interacting with the involvement of the IR tools and simulation, which is making the learning more effective. This new package of interactive maritime training through IR and simulation, it is also being inspired by the theories. There's two theories which we are based on. The first theory is about behavioral theory by Graham et al. 2013, and also the integrated theory that is being developed by Terry Anderson 2011 meaning. And this theory, which being applied in this package for new pedagogy, is the way how we can interact and how we can involvement of the student, and we design and develop a set of inquiry-based argumentative reality learning tools. Student could control, combine, and interact with 3D model of macro particulars using makers and conduct a series of inquiry-based experience, which is imposed and very important in new pace and a new innovative development which we are apply in this new pedagogy, and it also can be introduced to the society, namely name industry forwards era, where we use the companies in process of relevant product creation for the activity of IR4. The impact and the outcome of the ETNL of this new pedagogy stimulus interactive maritime training package will have in enabling industry forward skill for those industries which is having the emergence of the IR4 industry application. It is also very more flexible, handy and creative for the industries, trainees and the student who participates and can practices their new pedagogy stimulus. At the same time, also this can also enhance their cost effectively. The nobility of this new pedagogy concept is embedding IR and nexus simulation could always get the best learning experience, either by the student or the trainee of the or the participants of the industry who are applying this package. They are ensuring that the experience they are learning is the best, which can also ensure the ability of the future talent and equip the students and the industry trainees with the necessary skills sets to ensure they can work in the IR4 environment, which is the new emerging industry era. And at the same time also, the impact of this package is very vital for the human capital development, which is lacking in the maritime industry right now. Currently, we are also looking at the intellectual property rights IPR, in which is in the process as a recognition to boost up this package and to instill the usefulness of this new pedagogy package. It is also very useful for the maritime technology sector to upscaling and rescaling the graduate employability, that is GE. For the market potential for this innovation, we will have by having a creative module which can be useful for the industry, polytechnic, vocational colleges, and training institution in either local and international arena. So in conclusion, we can say that this invention is a fusion of advance in artificial intelligence, AI, augmented reality AR, virtual reality VR, and the Internet of Things IoT, genetic engineering, quantum computing, and other advanced technologies. This can enhance the student video creativity with integration of the real industry fieldwork simulations via new pedagogy stimuli package of this maritime industry, and it is also embracing the industry skill. I also put some of the sample where the student get some award on the competition of the green logistic and short logistic documentary film. With that, I would like to conclude that we also acknowledge this invention was funded by the Malaysian MOHE, our Ministry of Higher Education, in terms of the they are giving us the software for the IR4 Industry Revolution Competency Center. It is awarded by MOHE, Ministry of Higher Education. Thank you. For the last part, we would like to present a short activity from the student involvement. Please proceed, David.
This media will give a clear understanding how a tunnel bow thruster works. A bow thruster is a transversal propulsion device built into or mounted to the bow of a ship to make it more maneuverable. It consists of thruster, hydraulic cabinet, gravity tank, centralized control device, control panel. This represents the schematic diagram of a bow thruster system. Power is transmitted from the prime mover or electric motor through a flexible coupling, input shaft, bevel gears to propeller shaft, rotating the propeller in constant direction. Prime mover is an electric motor which drives the propeller shaft. The propeller parts consist of 4 propeller blades, a propeller hub with a hydraulic servo motor, and the sliding block mechanism. The propeller blades are connected to blade carriers by blade bolts, and this assures easy exchange of blades in the thruster tunnel. The gear case which carries propeller parts is connected to the thrust tube by bolts, and this assures easy overhauling of all parts inside the tube. Pitch control for a thruster is very similar to that for a controllable pitch propeller. This tube has inner and outer pipe through which a head and astern oil passes. The tube is ported at either end to allow oil flow and segregated by seals. Oil is transferred to the tube via ports on the shaft circumference, over which is mounted the OT box. The oil passing through the OT tube result in reciprocal movement of the servo motor piston. Pressurized oil from the solenoid valve is fed to the hydraulic motors via an oil transfer tube in the propeller shaft. This movement of the piston is converted to rotary movement of the blades by the sliding block mechanism. The OT tube is rigidly attached to the piston as the piston moves fore and aft, so the entire length of the tube is moved in the same way. A feedback mechanism is attached to the tube. This also allows for checking of blade pitch position from within the bridge.